Good morning, everyone. In today's competitive digital marketplace, understanding customer behavior is no longer just an advantage, it's a necessity. We are here today to present our framework for predicting purchase intent from e-commerce Clickstreams, a project that leverages behavioral segmentation and explainable AI to turn raw data into a strategic insights. We are Team Oren Host Club and we are excited to walk you through our approach. I am Suren, and the teammates who worked along with me are Kabilan, Yuvraj, Presan, and Vignesh. So each member brought a unique skill set to the table, and from data engineering to business analytics. So our project's mission is to convert the chaotic high volume clickstream data from a e-commerce site into a clear narrative about user intent. So we are working with a dataset from a maternity apparel store, which represents a unique challenge as it lacks direct labels for transactions. Our solution is a three-stage framework. First, we perform behavioral segmentation using an unsupervised clustering method called PAM to group users into distinct personas based purely on their on-site actions. Next, we move on to predictive modeling, where we train a powerful XG boost classifier to predict the likelihood of conversion for any given session. Finally, the perhaps most crucially, we use explainable AI with SHAP to interpret our model's decisions, uncovering the specific browsing and behaviors that drive purchase intent. The ultimate goal is to equip business with clear user persons, a reliable predictive model, and a practical recommendations to enhance both user and revenue.
Hi everyone, this is Pricing here, and I'm going to speak about the challenges of e-commerce data. The main challenge we are addressing is the nature of e-commerce data itself. Online stores generate enormous volumes of clickstream data, but often it is complex and anonymous. The key question for any online business is how can we move beyond just counting clicks and start understanding the intent behind them. Our project tackles this directly by building a system to translate these anonymous clicks into actionable insights that can genuinely boost conversations and drive revenue. Secondly, to guide our project, we focus on three fundamental business questions. Segmentation: can we identify distinct groups of users or personas based on how they navigate the website? Prediction: can we accurately predict which browsing sessions are likely to end in a purchase? Explanation: and most importantly, what specific user actions are the strongest indicators of an intent to buy? Thank you.
Hello everyone, this is Vignesh Raja and I would like to start about the methodology and approach. Our three-stage methodology was carefully chosen to address the specific challenges of our dataset. In stage 1, for segmentation, we choose partitioning around medoids with Govert distance. Unlike K-means, PAM is robust to outliers and crucial. Govert distance allows it to handle the mix of categorical and numerical data in our feature set, which is essential for getting accurate personas. In stage 2, for prediction, we selected XGBoost. The algorithm consistently delivers state-of-the-art performance of the structured data. Its built-in regularization, speed, and ability to handle missing values made it the ideal choice for building a powerful and efficient predictive model. In stage 3, for interpretable, we use SHAP, while other methods like LIME exist. SHAP is grounded in incorporative game theory, which provides more stable and theoretical sound explanation for our model's prediction. This allows us to move from black box to a transparent, trustworthy model. Next slide. Behavior segmentation in action. Our segmentation analysis was highly successful, revealing several distinct user personas. For example, we identified the goal oriented shopper. This persona is classified by very few clicks, short session duration, and direct navigation to specific categories. Their conversion rate is very high, around 85%. The clear business action here is to streamline their checkout process and offer quick add to cart features. On the other hand, the spectrum is the casual browsers who has long session with many click across numerous categories. Their conversion rate is low at just 10%. For example, This persona, the category should be the engage them with personalized recommendation or use exist intent pop-ups to capture their interest before they leave. By profiling these personas, we can move from a one size fits all approach to a highly targeted one.
I am Yuvaraj Jainar, so I am going to explain predictive modeling with XGBoost. So in the second stage, we built our predictive model using the XGBoost classifier. This wasn't just about training a model; it was about building a reliable and optimized one. We implemented a rigorous tuning process using a randomized search with five-fold cross-validation. This ensures that our model's hyperparameters are optimized for the best performance and that its accuracy is generalizable, not just a fluke on a single data split. The final model successfully met our KPI targets, giving us a powerful tool to identify high intent session with a high degree of confidence. So next is the understanding the explainable AI. So having an accurate model is one thing, but trusting it and acting on its prediction requires understanding why it makes certain decisions. This is the power of explainable AI. Using SHAP, we generated two types of insights. Global explanations like B swarm plots, which show us the most influential features across all sessions. This gives us a high level view of what behaviors matter most overall. Local explanations like force plots, which break down a single prediction for a specific user session. This allows us to see exactly which combination of actions led the model to classify a user as a likely buyer or not. This level of transparency is what turns a predictive model into an actionable business tool.
Our project has produced several key insights and a suite of tangible deliveries designed for both technical validation and direct business application. These include a reproducible code base on GitHub, ensuring our entire workflow is transparent and can be replicated by someone else. A clean session level dataset ready for further analysis. A persona profile report, which details the characteristics and behaviors of each identified user segment. The final was the trained XGBoost model, which can be deployed to score new sessions in real time. And finally, a business playbook, which has a concise summary that translates our complete sharp findings into clear and actionable strategies for marketers. So, coming to the critical part of a project was planning a proactive risk assessment. We identified 4 potential risks and established mitigation strategies for each. Data quality risk. Our purchase intent proxy might not capture every conversion. To mitigate this, we tested multiple proxy definitions and made sure to be transparently document the limitations. The second one was the interpretability risk. Sharp explanations can be complex. Our strategy was to focus our analysis on the most impactful features and use clear visual narratives. And the third one was the cold start problem. Our model is trained on tools and need data which may not reflect current behavior. We have mitigated this by clearly documenting the need for periodic retraining the new model for the new data. And the final one was the timeline risk. A 5-week timeline is ambitious. We manage this through a strict sprint planning and scope management, deferring any non-essential extensions to ensure we hit our core deadlines. So coming to our hosted website, this is our landing page. So we can see that just a short glimpse of what we are doing here, and just eye-catching header here to see how is the model accuracy and other customer personas are listed down. And here we have the 4 main tabs or main 4 features we have implemented here. So the first one is the prediction analysis, where the user can come in and give a new set of input data, and he would get the the prediction from the ML model and also get an LLM natural language response out of it. And the second one is the customer personas, where the particular from the given data set, we are the 4 main customer categories are found out with using the PAM clustering, and the 4 different types of customers are listed out. And here one of the examples are like goal-oriented shoppers, bargain hunters, and 2 more. And the third tab is the model performance, just to show like how good is our model and what can be improved from there, like my accuracy scores, metric score, ROC scores, and stuff like that. And the last one is an AI analytics agent, assistant agent, where even a non-technical user can come in and ask questions in natural language regarding like whether this customer will buy this particular product or something, and the AI based on the XGBoost model's predictions and also the SAP's explainable AI insights, it will give out a natural language response back to the user. So let's start. Yes, we'll get started with the predictions. So here there are certain session parameters that can be altered. These are basically the fields in the CSV we have trained in. So here the particular user can come and change the number of clicks per product, and he can choose the engagement metrics, similar to product exploration metrics. Price analysis, he can give the particular price of that product, and he can also mention like whether the customer has visited these type of category of products, and also at what time, what month, day, and like how location he has visited the particular web page. And clicking on this predict purchase intent, the XGBoost model already trained in, it gives out a score. It for this particular set of inputs, the model says that it's a low intent and probably he wouldn't buy out the product. And also the customer is matched to a particular cluster of cluster 3. So based on the cluster 3, we have already seen that the recommended actions is the general engagement strategies. This is because the particular user doesn't come under any like goal oriented shopper or something. He's just in mixed behavioral patterns. He doesn't show any particular pattern there. So based on these values from both the XGBoost model and also the explainable AI, both the context is sent to the LLM and the short AI generated insight is done, and also the business recommendation is given back to the user. And coming to the customer personas, here like each clusters are separated out, and what is the conversion rate of each cluster, and what are the recommended actions for each clusters are mentioned here. And also here just a short comparison of all the clusters there. And coming to the performance tab, this shows just the every scores of the model, like ASC score, accuracy, recall, and everything. And the what algorithm is being used here, what is the size of the training sample, test samples, and everything. And these are the insights from the SAP explainable AI. You can see that the category exploration rate is the most impactful one, and the least impactful one is the most frequent location. And coming to the chatbot here, we have given certain we can say sample questions where the user can come in. These are like frequently asked questions, and given the question like what is the most important factor for predicting purchase intent, and it shows like category exploration rate is the most important one. You can say like what is I am not getting it. If a non-technical person comes in and he doesn't know what is category exploration rate, you can just say what is this, and the AI agent would come back and say this is like a broadly used different product categories, and it is a high important one for the user to convert and actually buy the product. So coming to the last page, which is just our page of our wonderful team. We were a team of 5, and the technological stack used were that we Python mainly for every tool calls, and Flask for front end and back end, and Gemini for LLM calls, and LangChain for LLM orchestration. Thank you.